This exercise is about the growth of arithmetic and geometric sequences. Which type of sequence grows faster? It depends. Your job is to figure out what it depends on. The question when indicates that one type of sequence may be growing slower and then it will overtake the other type of sequence. When this happens, explain where they cross. For each set of sequences, find the first 5 terms. Then compare the growth of the arithmetic sequence and the geometric sequence. Which grows faster? When? For the first example, our arithmetic sequence has a first term of 7 and a common difference of 2. Our geometric sequence also has 7 as the first term and has a common ratio of 2. We need to start by finding the first 5 terms of each sequence. In the arithmetic sequence, term 1 is 7. Since the common difference is 2, our second term is 7 plus 2, or 9. To find each term, simply add 2 to the previous term. Term 3 is 11, term 4 is 13, and term 5 is 15. Now let's find the first 5 terms in our geometric sequence. We know that term 1 is 7. To get the next term, we multiply by the common ratio, which is 2. So, the second term is 7 times 2, or 14. Counting in the same pattern, term 3 is 28, term 4 is 56, and term 5 is 112. Which value do you think will be more, f of 100 or g of 100? The answer is g of 100, but why? All of the values of g of n are larger than the values of f of n except for the first terms. If the pattern continues, g of 100 will be much larger than f of 100. We could also notice that the geometric sequence is growing faster because it is multiplied by 2 at each step, while the terms in the arithmetic sequence are only growing by plus 2. Let's compare 2 other functions. F of n is an arithmetic sequence where the first term is 81 and the common difference is negative 3. G of n is a geometric sequence where the first term is also 81 and the common ratio is 1/3. We can find the first 5 terms of the arithmetic sequence by starting with the first term, 81, and adding the common difference, which is negative 3. In the geometric sequence, we can start with the first term, which is 81, then multiply by the common ratio to get each successive term. Which value do you think will be more, f of 100 or g of 100? The correct answer isn't as obvious on this one. Both sequences are getting smaller. The geometric sequence got smaller very quickly. So will g of 100 be smaller than f of 100? What is the value of g of 6? 1 times 1/3 equals 1/3. The numerator is going to keep being 1, but the denominator is going to continue to be multiplied by 3. So it's going to continue to be a fraction. At g of 100, it will be a very small positive fraction, or a positive number close to 0. What will happen to f of n when n equals 100? When will f of n equal 0? We will have to subtract 3 27 times before f of n equals 0, because 3 times 27 equals 81. After f of n equals 0, the function values will start being negative. So, f of 100 will be a large distance from 0 in a negative direction, while g of 100 will be a small positive fraction. Any positive number is larger than a negative number, so g of 100 will be greater than f of 100. This exercise is just like the one you did in class today. You know that the sequence is geometric. What does that tell you? To find missing terms in a geometric sequence, you need to pay attention to how many jumps you move from one given term to the other given term. The number of jumps will tell you how many times you multiplied by the same number, or common ratio. Recall that each time you move in a geometric sequence, you must multiply by the same number. So, if you began with a 3 and you jumped 4 times, and now the value of the term is 48, you would be looking for the number r, which makes the equation 3 times r times r times r times r equals 48 true. You have been writing the explicit equation for a geometric sequence since task 1.7. Recall that the explicit equation is based on the rule for repeated multiplication. r times r times r, and so on, equals r to the nth power, where n is the number of times r was multiplied by itself. In this exercise, you have been asked to use the recursive rule to find the explicit equation. The recursive equation is f of 1 equals 10, and f of n equals 3 times f of n minus 1. The rule tells us we are beginning with 10 and multiplying by 3 to get to the next term. F of 1 equals 10, so f of 2 equals 10 times 3, f of 3 equals 10 times 3 times 3, and f of 4 equals 10 times 3 times 3 times 3. How does the number of 3's compare to n? When n equals 1, we have 0 3's. When n equals 2, we have 1 3, and when n equals 3, we have 2 3's. The number of 3's is 1 less than the input number, or n minus 1. Thus, f of n equals 10 times 3 to the n minus 1 power.